Okay, continuing on. So for work coordinate page, not until the setup is complete with this screen be of much use. During the first part of the setup, it is not used. However, a major task during setup is to determine and enter the tool's position relative to the work's PRZ, your task to complete. After this, the screen makes sense. When finished, it shows the tool position relative to the PRZ. The screen is used exclusively during a program run since it tells where the tool is located relative to the datum reference PRZ. And a caution, if the new setup PRZ has not been entered into the control, this screen shows the tool's position relative to the last setup. Totally worthless information that's where we're at. If fixture offsets and tool compensations are used, they too must be effective to use a work coordination screen. Okay, continuing on, distance to go page, DTG. DTG is a super useful during program tryout. It's how much more the axis or axes will move to complete the current command, either within a program or during a manual data input command. We'll have more coming up on that, so keep that in mind. This is a very useful screen for testing new programs and also for setup functions. So for a trade tip to use DTG while a command is being executed, set the rapid or feed rate override dial to 0 to stop all motion. Then measure if safe or estimate if unsafe to reach in the real distance to go from a tool to destination. Will it hit chunks, vice jaws, or rapid into the work? If so, stop to find out why and then fix the problem. Compare the real DTG to the DTG screen. The tool has clearance to go the amount shown. Turn on the feed/rapid rate and let it continue. You might do this comparison a second time, stop the movement, and compare as it gets even closer to the DTG. So you never reach it into the measuring DTG if the spindle is moving. So we're talking about engaging this, and so make sure that it's paused before you do that. For the machine coordinates page, the data on this screen cannot be changed from the keypad. It is absolute. It displays the spindle's position on mills relative to machine home, or the turret's position relative to MH on lathes, even on machines that do not require homing. This information is very useful during setups. You will use it in several ways to set up tools, fixtures, and determine offset values. The key point is to the setup positions such as PRZ and fixture offsets are saved and referenced by the control with many machine home coordinates. For mode switches, many but not all controls have a mode selector or some other way of choosing an operating mode. It's designed to simplify operation by allowing only the needed functions for a certain task while making transparent all others. The mode switch also makes it possible for management to grant certain levels of responsibility by locking out some modes. This is usually accomplished by turning and removing a key. So here's an example. For safety reason, the memory function cannot be used when in jog mode. It will not run a program. Accessing to any automatic function cannot be started, and vice versa. If the memory auto mode manual functions will not work. So that just gives you some perspective on some of these things. So more buttons, dials, and knobs. We're not here to teach them all, just to get you the ball running. So we're doing a survey here. The text will clear up many of the missing facts. And so make sure you do reference the textbook, as we're just trying to give an overview with this lecture. In the way of assurance, if I or any instructor were to walk into the same machine shop just mentioned, we too would need a bit of coaching on control we've not run before. They all have their oddities and ways of doing things, but be assured they all perform the same function. So just another caveat, it's not just one particular person. Anybody needs to be careful before they just start doing working with the machine. Okay, I'll pause here and I'll continue on in a second.